Today we're going to be working on how to write notations on subset. So we have subset notation and we're going to be using different symbols on how to denote a subset in a given set. This is the symbol that we're going to be using for a subset. So in this particular notation, we will be reading this as A is a subset of B, or set A is a subset of B. Now if we can denote a subset, we can also denote a set that is not a subset of a certain set. So this one, we could have set A is not a subset of set B, depending on the elements that we have on that particular set. Now let's have an example on how we could use these notations on subsets. So for example, we're going to write the symbol for a subset and not a subset depending on the situation. So for example number one, we have two subsets. We have set A. We have two sets. We have set A, which is 1, 3, 5, 7, and we have set B, which is 1, 3, 5, 7, 9, 11. Now you will notice that in set B, we have more elements, which has 1, 3, 5, 7, 9, 11, and in set A, we only have 1, 3, 5, 7. And 1, 3, 5, 7 can also be found on set B. Therefore, A, or set A, is a subset of set B, because we can find all the elements of set A in set B. Now for the second example, let's say we have set A, which is X, such that X is a letter in the word proof. And in this word, we have P-R-O-O-F. And for set B, which is Y, such that Y is a letter in the word roof, we only have R-O-O-F. So in this particular case, set A is not a subset of set B because there's no letter P in the set or the second set or set B. So we can say that in a subset, the notation is not commutative, which means you cannot switch them around to be able to get the same result. So this is how we write the subset notation based on this symbol. Now, another condition or another property about subset is that for any null set, a null set is always included as a subset of any set. So for any set B, a null set is a subset of B according to the definition. And for any set B other than the empty set, then the null set is also a subset of B. Now, how do we use the null set to count the number of distinct subsets in a given set? So let's say we need to write all the distinct subsets of set A. And we have here set A given by 1, 2. So set A has an element of 1 and 2. And if we're going to write all the distinct subset of A, we can have 1, 2 as a subset or all the elements. We can also have subset 1 or subset 2 and the null set, because the null set will always be included in your subsets. So all distinct subsets of A would be 1, 2, 1, 2, and the null set. So all in all, we have 4 different subsets for set letter A, even though it only has 2 elements, because we can divide it and put the combination into use, so we'll have 4 in total. So let's have more example on how we can count the number of subsets and element in a given set. So you will see that we have 4 different sets from the top row to the bottom row, and we're going to be counting the number of elements of each row. So let's start with the first one. The first one, we have here an empty set, which is represented by the curly braces with no elements. So if we're going to count the number of elements of set 1, we can count 0 elements because it's an empty set. And by the definition of an empty set is always a subset of any set. Therefore, we have 1 distinct subset for this null set. So we'll have 0 element, but we have 1 subset for the first row. And for the second row, we have 1 element, which is A. However, for the list of the distinct subset, we can count 2 subsets right here, which is subset A, which is the total number of subset, and then, or the total number of elements inside the set, and then the null set, because the null set is always included as a subset. So here we have 2 distinct subsets for example number 2. And for example number 3, we have AB, and for AB, we have 2 elements, which is A and B. However, for the number of distinct subsets, we can have subset as AB, we can have set A, we can also have a subset of B, and then the null set. So in this case, our subsets would be subset AB, which is the total number of elements, or we can only have subset A, subset B, and then the null set, which totals 4 different subsets. And for example number 4, the last row, we have ABC as an element of the last set. So therefore, we have 3 different elements in our set, or in the 4th set. However, the number of all distinct subset would be the set itself, which is ABC. We can also have subset AB, subset BC, and subset AC. And we can also have a subset by itself, which is subset A, subset B, subset C, and of course, the null set, for a total of 8 different subsets. So this is how we count the number of subsets in a given set, and this is also how we can connect the null set in relation with the set notation.